Glaciers. When people think of glaciers, they typically think of towering chunks of ice which advance and retreat across the landscape in a cold climate. Yet, in a select part of the world there is a different type of glacier which is not made out of ice but rather salt. And, just like glaciers made of ice, these massive salt glaciers advance across the landscape, moving at a speed of approximately 2 millimeters each year. And, several of these salt glaciers are fairly large, covering more than 10 square miles. For example, one of these impressive features is 14 kilometers or 8.7 miles long and 560 meters or 1,840 feet tall. So, how did this salt glacier form? Why do salt glaciers move? This video will answer these two questions and discuss this geologic wonder. The various salt glaciers throughout the country are primarily found in a group of mountain ranges within southern Iran. The closest major city to these salt glaciers is Garish, which lies 35 kilometers to the west. The Zagros Mountains currently host at least a dozen of the more than 100 salt glaciers found throughout Iran. From satellite, many of these features can be spotted as they stand out against the lightly colored landscape. The beginnings of these numerous salt features started approximately 520 million years ago formation during the Cambrian period, when what is now modern Iran was the site of a shallow sea which was filled with salt water. Eventually, this sea retreated, and the remaining water evaporated and left behind large amounts of salt in the landscape. Over the next several hundred million years, the vast quantities of salt were buried by more than 1,000 meters thick of rock. As this burial continued, something interesting occurred. Over time, the overlying sedimentary rock became higher and higher density as it further compacted. Meanwhile, only negligible increases in density occurred to the layers of salt. Eventually, the contrast in density between the two adjacent layers became too great, and as a result the salt began acting like a very highly viscous fluid somewhat similar to rhyolite lava, albeit much colder, in combination with regional compression creating a fold.